In this video, you'll learn how to use probability to determine the best strategy to fix a given problem. But first, recall that the probability that two independent events, A and B, occur is the product of two probabilities, the probability of event A and the probability of event B. Let's take a look at an example. A computer game shows two rows of closed doors. The first row has 10 closed doors, 3 of which hide a prize. The second row has 4 closed doors, 1 of which hides a prize. A player selects one door from each row to reveal if there is a prize behind the door. The player wins if he or she reveals 2 prizes. The game creator notices that very few people play the game more than once. She decides to change it so that at least half of the doors in each row hide prizes. What strategy can the game creator take in order to make the change, but still give the game the greatest advantage possible over the player? Because at least half of the doors in each row must hide prizes, the first row will need at least 5 prizes, and the second row will need at least 2 prizes. For the game operator to have the advantage over the player, the probability that the 2 doors selected both hide prizes must be less than 50%. Remember, the probability of 2 independent events occurring is the probability of event A times the probability of event B. So, the probability of event A times the probability of event B must be less than 50%. Let event A be selecting a door with a prize in the first row. So the probability of A is 5 out of 10. Then event B is selecting a door with a prize on the second row. So the probability of B is 2 out of 4. So the probability of the 2 events occurring is 25%, which is less than 50%. So the strategy of adding 2 prizes to the first row and 1 prize to the second row will make at least half of the doors in each row hide prizes, while the game still has the advantage over the player. Now take a look at another scenario. A clothing store gives each customer a scratch-off ticket with 2 sections. The first section has 8 covered squares, only 1 of which is gold. The second section has 6 covered squares, 3 of which are gold. The player scratches off only 1 square in each section to reveal the colors, and wins 20% of his or her total purchase if they reveal a gold square in each section. During the last week of the promotion, the store will increase the number of hidden gold squares in each section by changing a total of 4 of the non-gold squares to gold, but in such a way as to minimize the number of winners. What strategy can the clothing store take when changing the scratch-off tickets for the last week of the promotion? The lower the probability of both rows having gold squares, the greater the advantage for the store to minimize the number of winners. To add 4 gold squares, you can add 4 to the first row and 0 to the second row, 3 to the first row and 1 to the second row, 2 to the first row and 2 to the second row, or 1 to the first row and 3 to the second row. To find the best strategy, determine which strategy results in the lowest probability. Remember again that the probability of 2 independent events is a probability event A times the probability of event B. Adding 4 gold squares to the first row and 0 to the second row means there are 5 out of 8 gold squares in the first row and 3 out of 6 gold squares in the second row. So the probability of 2 gold squares is 31.25%. Adding 3 gold squares to the first row and 1 to the second row means there are 4 out of 8 gold squares in the first row and 4 out of 6 gold squares in the second row. So the probability of 2 gold squares is about 33%. Adding 2 gold squares to the first row and 2 to the second row means there are 3 out of 8 gold squares in the first row and 5 out of 6 gold squares in the second row. So the probability of 2 gold squares is 31.25%. And finally, adding 1 gold square to the first row and 3 to the second row means there are 2 out of 8 squares in the first row and 6 out of 6 gold squares in the second row. So the probability of 2 gold squares is 25%. So the strategy that results in the least probability of winning, 25%, is to add 1 gold square to the first row and 3 gold squares to the second row. Now you know more about using probability to determine the best strategy for a given problem. See you next time.